Hey folks, how's it going? This is Mr. Murray coming to you with a breakdown here for the square root discovery. So hopefully you have found this in the lesson notes. Please make sure you label this 3-10. This is our handout 3-10 until or unless I indicate that it is another number. As Polydoku was our most recent numbered handout at 3-9. So please make sure you're numbering these because some of these handouts are very important notes that will need to make their way back into your folder or binder at some point. Okay, so in this lesson, and we've kind of talked about this already, but I thought that I would give us a little bit more time to work through this. You might remember that when we started to work with distance in the coordinate plane, we were doing quadrilaterals and coordinate proof. We needed to sometimes simplify square roots. So on my board, and we don't have access to this anymore, were some important numbers. All right, 9, 16, 25, 36, 49, and I think they went on for a while. I think that my poster goes all the way up to that wonderful student named me goes up to pretty high on that one. Okay, and so we talked about how to take a complicated square root and break it down. Okay, and this has to do with what we call the laws of square roots. Okay, and so this investigation's purpose is to discover those very laws. All right. So my first task is this. What I have is I want to know which of these 2, 4, 6, 8, 10 expressions has the same value, that is equivalent to square root of 36. Now there might be 1, there might be 2, it could be all 10. But what I want you to do is this. I want you to pause the video, and after you pause, I want you to do your best to figure out how many of these and which of them are equivalent to the square root of 36. Okay, and then when you're ready, unpause, and we'll see if you were right. All right. So by definition, the square root of 36, and this is where it gets tricky, and this is a nuance that I and my Course 2 honors kids, which is where we're going to probably be going next year, or even if you're in Course 2 CP, we battled this out, and what we learned is that the definition of the square root of 36 is that it is equal to 6. So one thing we're going to have to think about is x squared equal to 36 is not necessarily the same thing as 36. Okay? Because if I ask you what number times itself is 36, well, there's two numbers. It could be 6, right? But it also could be -6 because 6 squared is 36, 6 times 6, and -6 squared, -6 times -6 is also 36. However, whenever we're dealing with the square roots, by definition, you're only going to take the positive number, okay? Also sometimes known as the principal number, okay? So basically, we know now that 6 is going to be it. So we have 1. What other ones do we have? Well, are any of these equivalent to 6? Well, look at this here. This is the square root of 6 squared, and that is equal to 6. So this is also the square root of 36. Okay, and notice that the 6 times the 6 is equal to 36, so it appears these are equal. All right, I know the square root of 4 is 2, and I know the square root of 9 is 3. So this has to also be equal to 36, the square root of 36, or 6. What other ones do I know? Well, look, the square root of 1 is 1. So this is essentially 1 times the square root of 36, which is the square root of 36. And here, the square root of 9 is 3, and maybe you know that a half times a half is a quarter, so the square root of a quarter is a half. And 3 divided by a half, well, how many times does half go into 3? Or what times a half equals 3? The answer is 6. So this is also equal to the square root of 36. And you might know that 9 divided by a quarter is equal to 36. All right, is in other words equal to 9 times 4. So those are 3 of them. But as it turns out, if you were to put this into your calculator, this would also be square root of 72 over square root of 2, also equal to 36. This is equal to 36. This is equal to 36. But the only two, as it turns out, that are not equal to 36 are these two right here. And this is what we talk about when we talk about the laws of square roots. Okay, and by the way, if you don't believe me, well, I think we might have talked about how 12 is 2 times the square root of 3. And if I take the square root of 3 times the square root of 3, it becomes 2 times 3, or 6. Okay? So what we notice, and if we take a look here, 12 times 3, that's 36. 18 times 2, that's 36. Observe that 72 divided by 2, that's also 36. 9 times 4 is 36, and 1 times 36 is 36. Okay? And so what we have here is the laws of square roots. And what I'm hinting at here is that these will actually work, or potentially will work, for other roots. And why I'm getting at that is because, and I'm adding this note actually new this year, is that when you get to course 2, we're going to start talking about other types of roots. Cube roots. We could talk about fourth roots. And actually, we could really talk about whatever root we wanted. And so it actually would be cool if they worked for every root. But so far, what we know is this. We know that the square root of a product is a product of square roots. Okay, so that is the square root of A times the square root of B is equal to the square root of A times B. Okay, so for example, the square root of 2 times the square root of 18 is equal to the square root of 2 times 18, which is equal to the square root of 36, which is equal to 6. And so what's cool about this is that two numbers that are completely irrational, right? Square root of 2, put that in your calculator. It's like 1.41, blah, 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 blah. It goes on forever. Square root of 18, well, that's going to be 4 and some change. It's probably a little bit closer to 4 than to 5, but it will go on forever. And so yet, despite the fact that these numbers are irrational, they have no terminating or ending decimal, and it's just a bunch of random decimals. When you multiply them, you get a whole number. It's pretty cool. Okay, similarly, if I start off with something like the square root of 18, I know the square root of 18 is equal to the square root of 9 times the square root of 2, and the square root of 9 is 3, so I get 3 root 2. So what's cool is that it actually works both ways, okay? And I never thought about this before until recently, but those of you who are used to reading left to right sometimes don't look back and go the other way. And think about the fact that the square root of A times the square root of B equaling the square root of A times B could actually work the other way around, okay? And that's what we get with example 2. All right, now, the other thing we know is that we know the square root of a quotient is equal to a quotient of square roots, okay? And when we think quotient, we think division, okay? So what that means is the square root of A divided by the square root of B is equal to the square root of A divided by B, okay? And this is a similar idea to multiplication, right? Except now we're doing division. Keep in mind, technically we're not supposed to have b being equal to 0 because that's obviously going to cause a problem. You might see that come up in some textbooks as well. So here's my example from above. So I know that the square root of 9 divided by the square root of a quarter is equal to the square root of 9 divided by a quarter, which is equal to the square root of 36. Okay? Here's another example. Let's say I have the square root of, 72. So that's equal to the square root of essentially 70, or rather, maybe we could say 144 divided by 2. So it's equal to the square root of 144 divided by the square root of 2. And we're not in a place where we're ready to simplify this, so I'll kind of leave it at that. And so what we want to do here is our goal is to simplify these square roots as much as we can. We're not going to see the quotient come up this year. I'll put a star next to this. It's mostly the product that we're going to deal with, but it's good to know about the quotient as well. My little disclaimer here is that remember, when looking to simplify a square root, you need to find, and this is really, really important, you need to find a factor that is a perfect square. And now we've talked a little bit about what perfect squares are in terms of trinomials, right? Quadratics. So I've got 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, and so on. So I'm looking for 1, 4. Now 1, we're not going to really think too much about 1 because 1 won't change how things look, but it's a perfect square. And I guess 0 is 2, but we're not going to worry about 0 either. Okay? So the purpose of this lesson is to give us a little bit more practice with simplifying and kind of tweaking square roots before we move into a situation where we're going to have to work with a lot of square roots, oftentimes that need to be simplified. Okay, so please make sure you understood what I did here on this page. Please make sure your front side of your 310, where it looks now exactly like mine. And then when you're ready, go ahead and move on to the next part. All right, and so for the next part, this is going to be a pairs practice activity, okay? So what we're going to do is this. Okay, what we're going to do is this. If it's going to depend, what you do now depends on your last name. I'll put this in the Google Doc as well. If your last name begins with A through M, you're going to choose column A. And if your last name begins with N through Z, you're going to choose column B. Okay, so this is going to be our A's through Z's, our A's through M's, and our N's through Z's. What you're going to do for your column is you're going to come down the line, first row, second row, third row, etc. And you need to simplify the square roots. All right, and so you're going to know if your answer is right because in the final answer, the numbers inside and outside the root will be flipped. So for example, if column A gets 6 root 5, column B would get 5 root 6. Another example, if column A gets 2 root 3, column B would get 3 root 2. That's how you're going to know you're right. Okay, so please make sure, 1, you identify your column, and 2, you're ready to do the problems. Please make sure that you've made 310 entirely filled out, and rewind if need be. And good luck, folks. We'll talk more about this tomorrow. I'll see you next time. Don't forget to love math, and remember, you can do it. All right, take care, and I'll see you next time.